Thanks for giving us the chance to present OccuCamp. So this is the project that our cohort did for Team Challenge, and I'll tell you a little bit more about it. So we have talked about it in more details in our last webinar. So if you're more interested in hearing more about it, you can let us know, or also watch the other webinar that will be uploaded in the next days. So what we did during this Team Challenge is to build a room occupancy monitoring system. And as you probably already know, so we were given this problem that COVID has forced us to reduce occupancy in the labs, and that's to do it manually. It's a bit difficult, so we were given this challenge to find a way to help in allocating people, and also to help in counting the number of people, so they get a sign if people exceeded the number in that specific lab. By the way, this is our cohort, and I think we're very proud of giving this interesting challenge, and also making some good progress to make that happen. So here is what the idea that we came up with is to build a sensor that can be mounted on top of a door, that can then count the number of people that are inside the room and the people who have left, basically. And we were given some requirements, or maybe these actually, some of them we came with ourselves, that the system needs to be anonymous, so it doesn't identify individuals. It's really easy to install, it's low cost, and doesn't require any battery, so it's a passive sensor. And after giving it a lot of thoughts, the team has developed this sensor, which we made ourselves. So it's in the sensor itself, we have a thermal sensor that detects the heat of individuals, and that is then connected to an Arduino that records all these signals. And because the Arduino is consuming a lot of energy, we decided that what we would do is we would only turn it on when the door is open. And we did that by connecting it to a magnetic door sensor. So the sensor is only on when the door is open. And finally, the data is sent to Raspberry Pi, where it's analyzed and then sent to a web server where it can be displayed in a map that I will show you. So this is our sensor. And this is basically the map. So we made the map from scratch. And on the right, you can see when Hayden entered the room color has changed. And when he leaves in a bit, the color will be back. And the system was about 70% successful in identifying people entering and exiting the room. So it's something we're really proud of, and especially that we did this through the pandemic and we had to do things online. I'll tell you more also about another thing that we started as a Sensor CDT students, which is something I think we're really proud of as well, is we started this initiative to help underrepresented students. We can do really well in research, and our motto is to help people become research champions, and I'll tell you more about this program. So this is the team that started this initiative. As you can see, all of us are Sensor CDT. Even the people who are not Sensor CDT, they're actually from other CDTs, which is very interesting to see. And this is the current team, the committee team. And now we're really happy to have Professor Roshin and joining us as a senior treasurer, and Professor Gabby Kaminsky as our board member. And now we're working harder to bring in people from Cambridge, because what we're working on is to bridge in both Cambridges together to come with a really high quality research training program. And we have more than 150 active volunteers as well. These are our funders, and without them, none of this would be happening, especially the Sensor CDT. They gave us really big grant to start with, relatively, I guess, to starting, and helped us a lot get out of the ground. So what is our mission? So our mission is to enable underrepresented individuals to do outstanding STEM research, and those can be anybody who is less represented in universities, especially top universities. And we aspire to offer the best research training in the world in the next 2 to 3 years. We already think that we have really high quality research training, but we want to reach the top because we are from the top. We have Cambridge and Harvard. And we want this to be accessible to anyone, anywhere. Like anybody who take our program, they feel like they have done research in Cambridge potentially, because they will learn all the skills that we learn as well. So this is what we want to achieve in the next 2 to 3 years. And in the future, in the next 10 years, we want to enable anyone, anywhere to do outstanding research. So what is our program? Our program is about 6 to 8 weeks, and we call it a mini PhD program because we try to equip the students that enter with all the skills that they would learn in a PhD in Cambridge or Harvard universities. So we cover things like how to design an experiment, how to do literature review and write research proposal, how to run an experiment successfully, how to analyze data and critically think about the data and research papers, how to make a presentation, write a report and a paper, and other professional and personal skills. And to bridge all of that, we teach you at the end how to make an outstanding application, whether that's for a career or for a PhD. And this is our first program. We run it, we had 4 students, and we gave the students a sensor that was actually made by other sensor CDT students. It was, I think, 2 years ahead of us. They made a sensor that monitors air pollution, and the students used the sensor to address a new scientific question, which is the air quality inside the kitchen. The results were really interesting, and the students were really happy with how much they progressed in such a short time. Now the program has expanded a lot with a lot of volunteers and interest from Big Cambridge and from the UK and from globally as well. So now we have 3 streams. The first one we are planning to run in January. It will include high school students for 3 countries. We're starting a program in December 20th with Anglo Ruskin University, and next year we're starting another one with Samstrang Group. And the upcoming program, which we're really excited about, that's going to run in the summer. Now it's going to be for 28 countries, and we have secured 3 countries now with collaborations. So that one will be our highlight next year. We also have more advanced programs for master and PhD students, and we were supposed to start our first in Ethiopia this month, but unfortunately a war started in Ethiopia and we postponed it. Hopefully we're going to be able to do it. If not, unfortunately, we'll have to move to a different country. So in terms of, you've noticed that we focus a lot on sensors. Most of our projects are on sensors. Sorry, I need to mention this quickly. So with the UK programs, we are using Open Seneca device. Samstrang, we're going to use a sensor as well. For the global program, we're going to use a glucometer. For the Ethiopia program, we were going to use a microscope. So as you can see, all of them are sensors, because we notice sensors are accessible really easily. They can be used by anyone. You can do research with them really easily as well. So yeah, for the global program, we're going to focus on diabetes. So the program will be made of 2 different components. So the first component is testing the precision, accuracy, and specificity of glucometers across the 30 countries or 28 countries. And the other part is a survey research based problem where the students will try to identify what are the gaps in awareness in that country or in that city. And then when we identify these gaps, we're going to communicate with organization that works on this to help them improve their raising awareness programs. And the program will be offered for high school to undergrad to master students. In terms of the project in more detail, so we will accept 20 students from each country, from 1 university, and then they will be breaking down into 4 different teams, and they will investigate many different things, such as the specificity, precision, and accuracy in terms of brand, age, principle, and cost. And they will also look into supplements and drug. So how would the supplement and drug affect the readability of these sensors? So each team would potentially identify a supplement and a drug, and they will look into this. And in terms of the program, will be 8 weeks, as I said. So we're going to cover very similar skills. So initially starting with the basics, personal and professional skills with some data research and research design and writing, and then the student will run these experiments, and then we'll teach them how to do analyze the data, making the presentation, and we will end this with a conference as we usually do. And I just want to mention that our support doesn't end by the end of the program. We continue supporting these students throughout until they even finish their PhD. There's something I'd like to mention about the conference. So we always end our program with a conference, and we try to make a really high quality conference. We invite speakers who are at the top of the field. For example, in our last conference, we invited Professor Roy Harrison, who's one of the most cited in the field. So we want to give these students really, really high quality access to these conferences and to these people, to give them feedback, to help them build this network, and most importantly, help them to build the confidence. And one thing we really interesting, we noticed in this conference that the majority of people who attended were from the developing world, because they cannot attend this conference. They are so expensive and they have no money to go to high quality conferences. So we were really happy to have a high percentage of the people who attended our conference are from the developing world. And this also helped us establish more collaboration. We were approached by PhD students from University of Nigeria in Osaka, and they want to also start a program there as well. That's about it from our end. I hope this gave you some insight on what students can do or would do in the sensor CDT.